Okay, for lab 3, I have my 7-segment driver file, and for this lab, I basically used most of the segment 7 driver template that you had in the topic grid, and then I modified it a little bit. So I took away the digit 3 and digit 2 because those were unnecessary for this lab, and I have my constants set the same, and I erased the A through F7 segments since they were unnecessary for this lab. So it's just 0 through 9. Then it goes through the binary to 7-seg, 4 digits, and then it goes with the digit select, and it selects digit 0 when it's 0, 0, selects digit 1 when the others, and then the selected blank I left the same. That selects the current digit to display. And then with the anode select, I modified that when else statement, where I took away the when 0, 1 state and made that the when others, since I'm not using digit 2 and digit 3. And then the scan rate's the same, and the process, the digit count stays the same. That generates the digit selection. So in my lab 3 component, file that contains the component 7-seg driver, I poured in the clock, the switch, the anodes, and the segments. And then I have my constants to disable the reset, to enable the digits, disable the digits, the active, and also to set digit 1 to 1 all the time, since we're just going from 0 to 16. And I have my constants for the 7-seg and 4 digits, just like I do in the 7-seg driver file here. Well, not like that file, but I have them set like that file from 0 to 9. Then I have a blank digit signal and my digit 0 value signal, and I poured in my reset clock digit 1, digit 0, blank 3, blank 2, blank 1, blank 0, 7 segs, and the anodes. Then I assign them to the proper constant. So reset gets disabled, which means it gets a value of 0. Clock, it gets assigned to the clock. Digit 1 gets assigned to 1. Digit 0 assigned to the 0 for digit digit 0. Blank 3 gets digit disabled, which means the digit is disabled by sending it a 1. And then blank 2 also gets this digit disabled. Blank 1 gets a signal, blank digit 1. And blank 0 gets digit enabled, which sends it a 0. 7 seg gets to the seg, assigned seg. Anodes assigned to AN for the anodes. And then my switch count process, I have count and a value. From the count ranges from 0 to 16, and the value ranges from 0 to 9. And so it just counts the number of switches on, stores that in the count variable. Then I have a quick if statement that turns on digit 1. So when count is greater than 9, digit 1 is enabled, and the value is count minus 10. Since count cannot exceed the value 9, well, the digit cannot exceed the value of 9. Else, the blank is off and value equals count. And then to display the proper value on my display, I have a case statement that takes in the value. So when it's 0, it gets assigned the binary value, a 4-digit binary value of 0. When it's 1, the binary value for 1, and 4 bits. 4-bit value of 2, 4-bit value of 3, 4-bit value of 4, and so on through 4-bit value of 9. And then for the test bench, I have the ports. I poured in the components from lab 3. I poured it in the inputs and outputs from lab 3 file, and I have a signal. So switch segments, the anode, the clock, and a signal for check done that I run to check my loop, so it runs for 30 cycles. So then in my procedure, it takes in a period, the signal, the clock, the variable, my delay, the counter starts at 0, and it runs as long as the counter does not equal 30. And it creates the rising edge and the falling edge of the clock. And then, the test is switches and the segments and anodes, and clock gets assigned the signals. And in my waveform, my test bench, I check all 16. I check 16 possible inputs being on. And in a simulation, 0 switches are on flip. 0, the only segment that is off is segment 6. And the anodes, all those are off except the first anode 0, while the clock is going up, incrementing up and down. And then when one switch, and also if you notice, the values for the anodes are all 1 here, which means that segment segments 1 and 2 are on for a 1, which means this is the one digit 1 that are blanked right now, and this has set the 1. And one switch is on, and the segments represent the value of 1, and anode 0 is on. Same, and anode 1 stays the same. Then 2 switches are on. The segments represent the value of 2. The anodes represent just anode 0 on, and also anode 1 stays same as off. Then switch 3, when the 3 switches are on, and the segments display the value of 3. The anodes 0 is still on, it's the only one on. And then 4, also the blank digit stays off, but it still sets the value of 1 with the segments. And then when there are 4 switches on, then the anode 0 is on here. It displays the value of 4 with the segments, and then the 1 is off. For the anode 1 is off, and it's still displaying the value of 1. And when there's 5 switches on here, anode 0 is on. The switches represent the value of 5, and anode 1 is still off, and it still represents the value of 1 that stays the same. Now it transitions to seeing the hardware implement on the board. I flip each randomly to count from 0 to 16 and back from 16 down to 0. 1, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, and 16, and 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, there's 2, 1, 0.